morning. So I'm going to go ahead and finish this recording. Hold on. I have to make sure it's not going over the other one. Okay, so let's finish up this. So that was going to be quantity 1. It's in the middle. Okay, and then quantity 3. So since this is going to be our middle. Okay, we're going to have the third one. So if I look at the upper quartile, the middle, okay, it's going to be the 350. Okay, and then quartile 1, so I look at the lower half of the data, the middle of that one, the middle quarter, okay, is going to be 190. Okay, so that's quartile 1. What is quartile 4? Everybody is always the highest number, so that's 400. Okay, so everybody, if we're doing our box and whisker plots, remember it's between, our box is between quartile 1 to quartile 3, and then we would have our whiskers. Okay, Savannah has $30,000 in property damage insurance and $7,000 in comprehensive and collision with a $500 deductible. One evening she slides on a patch of ice and hits a parked car, causing $3,400 in damage. Accident causes $2,250 damage to her own car. How much will she have to pay? Okay, so the comprehensive and collision protects her car. She is only going to have to pay the $500 deductible because she has comprehensive and collision insurance. Okay, so that protects hers. Okay, so that protects your property. So that's going to protect you. Okay, property damage, liability protects others. Okay, so this is all she would have to pay. So just her $500 deductible. Okay, Tom Payson's insurance card monthly. His annual premium is $1,275. So annual. Each month he's charged a $2 convenience fee. If his annual premium is divided equally into 12 monthly payments, how much is this fee? So we're going to divide this by 12, and then we're going to add the $2 convenience fee. Okay, and that will give us his the insurance monthly payment. Okay, so I got $106.25. I'm going to add the $2 fee. So Tom is going to pay $108.25 each month. Okay, so this one, the car is depreciating at a rate of 4.6% per year. He brought a 4-year-old Honda for $17,600. What's the original price? So we're solving for A. So A is going to be equal to the used price divided by 1 minus the rate as a decimal raised to the x. Okay, so we're going to substitute it in. So this is y. Okay, so 17,600 divided by 1 minus the rate as a decimal. Drop the percent sign, go to the left, add the decimal and the 0. That is going to be our original price. So we get okay, so I got $21,248.05. Okay, so this one, Laura brought a 4-year-old Chevy truck for $16,700. When it was new, it cost $24,475. Find the depreciation rate, so that's R. Okay, so remember, so R is equal to 1 minus Y is the used price, A is the original, raised to the 1 over X. Okay, so X is going to be 4 years, used, so Y is the 16,700. When it was new, it cost 24,475. So it's going to be 1 minus 16,700. Everybody read these problems carefully. Over 24,475. We're going to do 1 over 4. Okay, so I got 0.09113. I'm going to multiply that by 100. That's our last step, everybody. Okay, remember 5 and up rounded up, so I look here. That's less than 5, so it's going to stay the same. So 19.1%. 9.11%. Okay, this one, Jessica's new car cost $23,000, depreciates at a rate of 4.285% to 8,456. How long did it take? Okay, so everybody, that means that we're solving for the time. So it's going to be y over a. Remember, this is a fraction problem. And then 1 minus the rate is a decimal. Okay, so it's going to be natural log. Okay, a new car. Okay, so that's going to be a. Our 8,556 is going to be our y. Y is always going to be the lower number. Remember to change the rate to a decimal. And I got, it says round to the 10th, everybody, so that's the first decimal place. So it's going to be 20.4. Okay, so the car depreciates. Okay, so it's going down. Some 7 2/10 per year. David brought a used Honda for 18,600. How much will it be worth after 3 years? Okay, so everybody, that means we're solving for y. So y is equal to the price starting value, and then 1 minus the rate is the decimal raised to the x. So he bought it for 18,600. And then 1 minus the rate is a decimal, so 0.072. And after 3 years, so everybody, that's our x value. So the value is going to go down to $14,864.72. Okay, so it says a car's traveling average rate of 55 miles will drive 356.7 miles. How many hours? So everybody, we are doing the distance is equal to rate divided times time. Okay, so everybody, this is the division. Right here means we would multiply. So we're solving for time, everybody. So we're going to divide distance divided by the rate. We're going to put in the distance. Okay, so that's going to be 5.48, 5 and up, rounded up, so it's going to be 5.5 hours. Okay, your total stopping distance with a speed of 70, round to the nearest foot. Okay, so everybody, that's the whole number. So it's going to be speed plus speed squared divided by 20. Okay, everybody, so that's total stopping distance. So it's going to be 70 plus 70 squared divided by 20. So 315 feet. Okay, Trevor is driving on a freeway going 62 miles per hour, sees a traffic jam 210 feet away. How far is he enough to safely stop? Explain your reasoning. Okay, so basically we're going to use this formula again. Okay, so we're going to go 62 plus 62 squared divided by 20. I got 254.2. Okay, so which would round to 254 feet. Okay, is he far enough away to safely stop? The answer would be no. Okay, his stopping distance, okay, is more than 210 feet. Okay, it's more. If it was less, it would be yes. Okay, or equal to. A car traveling on asphalt makes a sudden stop. The drag factor of the road is 0.5 and the brakes were operating at 80% efficiency. If the car leaves 3 distinct skid marks that are 61 feet long, what was the speed of the car entering the skid? Use whole numbers. Okay, so everybody, so speed is equal to, okay, remember it's going to be 30 times the skid distance times the drag factor times the braking efficiency as a decimal. Okay, on the calculator, everybody remember it's second. X squared to get this. Also make sure, everybody, that you do the parentheses. Okay, so that it will do that for you. So it's going to be 30 times 61 times the drag factor, so 0.5 times, this one is, we're going to drop the percent sign and go to the left, everybody. So for 80%, okay, think of it as pinning the tail on the donkey. Decimal's right here. I'm going to drop the percent sign. I'm going to go to the left. Okay, so it's 0.8. Okay, so I get 27.05, 5 and up, rounded up. So our speed is going to be 27 miles per hour. So that would be my answer. Okay, good luck, everybody. You got this. Make sure you make your cardstock with the formulas on it.